way.
Hi, I am Jackie, and today I'm going to discuss about the Bernoulli's equation theorem. So the Bernoulli's equation theorem was formulated during year 1738 by the Swiss mathematician and physicist Daniel Bernoulli. So the Bernoulli's equation goes pressure over the unit weight of fluid plus the square of velocity over 2 times the value of the gravity plus z, where z is called the head difference, v squared over 2g is what we call the velocity head, and the pressure over the unit weight of fluid is the pressure head. So now, let's relate the Bernoulli's equation to the energy, which applies the principles of conservation of energy. So here we have energy equation without head loss. The formula says E1 equals to E2, where it says to be expanded pressure 1 over the unit weight of fluid 1 plus the v squared or the velocity of the section 1 over 2 times g plus z1 equals to the pressure 2 over So it says that the energy equation without head loss says pressure 1 over the unit weight of fluid plus squared of velocity 1 over 2g plus z1 is equals to pressure 2 over the unit weight of fluid plus velocity of section 2 over 2g plus z2. And so here we also have energy equation with head loss. And it says here that E1 minus head loss is equals to E2. Same as this, but the difference is we're going to subtract the head loss in this equation number 1. So here, if we expand this equation, we have pressure 1 over the unit weight of fluid plus velocity over 2g plus z2 minus the head loss between the section 1 and 2 equals to the pressure 2 over the unit weight of fluid plus the velocity over 2g plus z2. So now, are we ready to solve some problems? Have a problem. It says water is flowing in an open channel at a depth of 2 meters and a velocity of 3 meters per second. It flows down a chute into another channel where the depth is 1 meter and the velocity is 10 meters per second. Neglecting friction, determine the difference in elevation of the channel floors. So here it says that the depth of the water is 2 meters. And here at this point, the depth of the water is 1 meter. And the velocity flowing from this point is 3 meters per second, while the velocity flowing at this point is 10 meters per second. So first, to solve a problem, we are going to write the givens. So the first given is a depth of 2 meters. And we are going to denote it as and the velocity of 3 meters per second. So here are the givens. h1 is equal to 2 meter, velocity 1 is equal to 3 meter per second, h2 is equal to 1 meter. So since we already have the givens, we are now ready to solve the problems. So here, if we're going to read the problem, it states here that this problem is neglecting the friction. And this notes that this problem has no head loss. So since this problem has no head loss on it, it gives us the idea to use the equation of the energy equation without the head loss. And as we had discussed earlier, the energy equation for that is E1 is equals to E2. So to expand this, we have this equation. So pressure 1 over the unit weight of fluid plus the velocity to the second power over 2g plus z is equals to the pressure 2 over the unit weight of the fluid plus velocity of the second section to the second power over 2g plus z. So here, since the problem states that the water is flowing in an open channel, and that includes that the pressure acting here up to here is 0. Since the only force acting on this side for the water to flow is the gravity. So we're going to denote P1 is equals to P2 is equals to 0. So since we already have the givens, we are now going to substitute this to this equation right here. So, pressure over the unit weight is equal to 0, plus the velocity in section 1 is 3 meters per second. So, 3 meters per second squared over 2 times the value of the gravity is 9.81. Plus the height or the depth of the water flowing in this section is 2 plus the head difference, which is z, which is unknown, and here 0 plus 10 meter per second squared over 2 times 9.81 plus 0 for the z, but we have a depth of 1 meter. So let's solve it. So this equation gives us the value of 0.459 plus 2 meter plus z equals to 5.097 plus 1. So, in order to find the value of z, we are going to transpose these values here to here. So z is equals to 5.097 plus 1 minus 0.459 minus 2. The answer is 3.64 meter. So here we have the value of this head difference from this point to here. The value is 3.64